According to everything astronomers know about stars, Stephenson 218 should not exist. A star can only grow so large before physics begins to push back. Gravity weakens its grip. Powerful stellar winds blast material into space. The larger a star becomes, the harder it is to survive. At least, that's what scientists thought. Then, astronomers discovered a star so enormous that it appears to sit beyond one of the most important limits in stellar physics. A star this large should have torn itself apart long ago. It should have shed its outer layers. It should have stopped growing. Yet somehow, it didn't. Hidden nearly 19,000 light-years away, Stephenson 218 may be one of the largest stars ever discovered. And if astronomers are right about its true size, the mystery is bigger than the star itself. Because this is no longer just a question about one strange object. It is a question about whether we truly understand how stars live, grow, and die. For decades, astronomers believed they understood the limits of stars. Inside every star, two forces are locked in a constant battle. Gravity pulls inward. Nuclear fusion pushes outward. As long as those forces remain balanced, the star survives. But the larger a star becomes, the more fragile that balance gets. Imagine building the tallest skyscraper on Earth. Eventually, the weight itself becomes the problem. Stars face the same challenge. As massive stars expand, their outer layers become increasingly difficult to hold together. Powerful stellar winds begin carrying material away into space. In a sense, the universe has a built-in safety mechanism. If a star grows too large, it becomes its own worst enemy. That is why astronomers believed there had to be a limit. Then they found something that appeared to have crossed it. Hidden inside a distant cluster of massive stars was an object that seemed impossible. At first, it looked like an ordinary red star. Then the measurements came back, and they didn't make sense. The star appeared to be more than 2,000 times larger than the Sun. Not twice as large, not 10 times as large, more than 2,000 times larger. If it replaced our Sun, its outer layers could stretch beyond the orbit of Saturn. According to existing models, a star approaching that size should be struggling to survive. Yet there it was, and the strangest part was not its size. It was the possibility that the measurements were correct, because if they were, Stephenson 218 was not simply one of the largest stars ever discovered. It was a challenge to everything scientists thought they knew about giant stars. The first problem is size. Imagine removing the Sun from the center of our solar system and replacing it with Stephenson 218. Mercury disappears, Venus disappears, Earth disappears, Mars disappears. Even Jupiter could end up inside the star. If Earth orbited Stephenson 218 at the same distance it currently orbits the Sun, our planet would already be inside it. A single star occupying a region of space normally filled by planets. The second problem is survival. The larger a star becomes, the harder it is to hold itself together. Its outer layers drift farther from the core. Gravity weakens. Stellar winds tear material away and hurl it into space. In theory, this should act like a natural brake. The star grows, it loses mass. Growth slows down. Yet Stephenson 218 appears to have pushed beyond that point. Then comes the third problem. Astronomers are not even certain exactly how large the star is. Stars like Stephenson 218 do not have solid surfaces. Measuring them is extraordinarily difficult. But here is the remarkable part. Even when astronomers use conservative estimates, Stephenson 218 remains one of the largest stars ever observed. The anomaly survives every correction. The debate is no longer whether the star is extraordinary. The debate is how something so extraordinary managed to exist at all. Scientists are trained to doubt extraordinary results. When an observation appears to break the rules, the first instinct is skepticism. The measurement must be wrong. The calculation must be wrong. The observation must be wrong. That is how science protects itself from mistakes. But Stephenson 2.18 refused to go away. For astronomers, that leaves only two possibilities. Either the measurements are misleading, or nature has created something far stranger than expected. Neither answer is comfortable, and that is where science becomes most interesting. Not when everything fits, but when something refuses to. Somewhere nearly 19,000 light-years away, a star larger than entire planetary systems is quietly forcing astronomers to question assumptions they once considered safe. Every new observation brings hope of a clear answer, and every new observation seems to replace one question with two more. Because the greatest discoveries rarely begin with answers. They begin with a contradiction nobody can explain. For now, Stephenson 2.18 remains an unsolved puzzle. How large is it really? How did it form? And perhaps the most unsettling possibility of all. What if Stephenson 2.18 is not unique? What if it is simply the first example of something astronomers have overlooked? The next generation of observatories may reveal whether Stephenson 2.18 is a rare cosmic accident, or evidence that scientists have misunderstood one of the fundamental limits of stellar evolution. The question is not whether Stephenson 2.18 is strange. The question is whether it is trying to tell us something larger. Because if this star is not the exception, then the real mystery may be how many others we have failed to recognize. At the beginning of this story, Stephenson 2.18 seemed to present a simple problem. A star that should not exist. But perhaps that was never the real mystery. The real mystery is how often the universe refuses to stay within the boundaries we create for it. Again and again, humanity has searched for frontiers. The highest mountain, the deepest ocean, the furthest galaxy, the largest star. And every time we think we have reached the edge of what is possible, nature quietly places something beyond it. Stephenson 2.18 may be one of those moments. Not because it is the largest star ever discovered, but because it reminds us that every frontier we reach may simply be the beginning of a larger one. The universe does not reward certainty. It rewards curiosity. Because every time we think we have found the limit, the universe reveals something beyond it. And the greatest discoveries often begin with something that should not exist, and then refuses to be ignored.